Typically, when thinking through how to create a biomechanical model, we like to start from a segment that the other segments can be defined from. The pelvis is a good example of this because the pelvis is where both the right and left thighs connect, and therefore the shanks and the feet are indirectly connected to it as well. Similarly, the thorax is also connected to the pelvis. So that is exactly where we're going to start in our exploration of this model. The pelvis is defined as having the proximal and medial references, we're talking about the two, as right hip and left hip. Now, the first question that might be arising is, where are these markers coming from? Because they're not technically markers. They are actually landmarks. What you'll see within this model, if you click up here on landmarks, and make sure you're looking at landmarks, you see all of these landmarks have been defined. And here we have right hip. We double click on right hip, we can get an idea of how this landmark was defined. What it has done is, starting from hip mid, which should be this landmark right here, you see hip mid. We will get around to talking about that. So it starts from hip mid and moves in the X direction within the lab segment, a distance of 0.36 times the width of the ACES. Now, these values come from Bell et al.'s papers from 1989, 1990. And what we have here is an example of defining a joint center based on literature using anthropometric data, but not necessarily based on marker data. So a lot of this still seems a little sketchy. Where is all this information coming from? Well, if we go back to landmarks, we can look at the hip mid landmark. How was it defined? Well, hip mid was defined simply within the lab segment in the Z direction, so vertically, manual hip height. You say, okay, where does that come from? Well, manual hip height is actually a piece of information that you either measure or you're getting from your Xsens data collection. This is going to be raw data that is input to Visual3D, giving it information about the height of this marker. So, knowing that our hip is defined from this marker, hip mid, in the X direction. So you might be wondering, where is or how is the lab defined? So the overall lab has an X direction, a Y direction, and a Z direction. So using X, Y, and Z, we can define anything within this lab. From our subject, we measure or obtain this height. This is the hip height. We input that, we obtain the location for this hip mid marker. And then that combined with this ACES width, which again is a measured value that is, we have a default in Visual3D for, having this ACES width from that marker, you can get to our hip as it's defined in the X direction. So I hope that's clear. We're using these three-dimensional coordinates to first move from the origin in the Z direction. So we're going up in the Z direction all the way to hip mid, defining that as a point, and then we move from that in the X direction 0.36 times that ASIS width. So that's how we get our hip. Obviously, L hip is defined in the same way. So if we go back to segments, you can understand how R hip and L hip are defined. Similarly, L5 is a landmark, which is also defined within Visual 3D. We're going to go ahead and close the tabs. So close tab, and hip mid, close tab. See L5 right here? If we double click on that, it also starts from hip mid. But this time, it's defined as going in the Z direction. Again, using a measured length in the vertical direction, which is the pelvis length. Most of these landmarks in some way come from measurements that are obtained from your Xsens data collection. So that's how this is a generic model that then is calibrated to your subject based on their specific anthropometric data. So back to segments, you see that is the actual definition of how we get our pelvis defined using three individual markers, or better landmarks, to define it so we get the position and orientation. If you've gone through the Visual 3D Basics course, you may notice that there is a little bit of an inconsistency with typical pelvis definition, as the proximal end of the pelvis is the hip end. So right hip and left hip are the proximal end, where we usually are talking about it the other way around. However, within Visual 3D, it is possible to spin things around. In fact, if you look at segment properties, you'll see it was defined using a model file called pelvis greater trochanter to iliac crest. So it's actually going the opposite direction from the traditional pelvis that we've used. One of the advantages this gives us is, we click on pelvis, you can see the origin for the pelvis is here. That hip mid marker is going to be the actual origin. So the coordinate system of the pelvis, which is different from the coordinate system of the lab, actually is the midpoint between the hip joint centers, rather than, as it usually is, being the center of the upper end of the pelvis. It's just an important detail to understand in the event that you are using this data for something more complex. So we've already talked about the right thigh for illustrative purposes of what a segment is in the previous chapter. So we're going to quickly tackle the right shank, which you can see here, the right knee center, and the right ankle center markers are defined as such. Now the right knee center is also used to define the thigh segment, but where does it come from? Well, if we go to landmarks again, let's go look at right knee center. And what you notice is it starts at the right hip and it's moving within the lab coordinate system in the negative z direction the length of RTH, which in Visual3D, RTH is the thigh. Again, if you go through Visual3D Basics, we talk about these codes, but this can be helpful to understanding what's happening. Similarly, for the lower body, we have RSK, which is the shank, and RFT, and actually I wrote thigh, shank, and foot. These are actually the right thigh, right shank, and right foot, where LTH would be the left thigh, LSK would be the left shank, and LFT would be the left foot. So if we go back to segments, you see that right knee center was defined exactly the length of the thigh vertically down within the lab to define that knee center. Now this is important to understand that this is not coming from a subject. We are creating our model exactly in a perfect anatomical pose. So everything is perfectly upright. Now why does this matter? Well, if you're coming from traditional motion capture, we record a static trial and we assume our subject is standing almost in a net neutral pose, but we know they're not, so we make some adjustments for the offsets that they are introducing. We're not pretending like our subject stood in a perfect anatomical pose. That might bring you to question like, well, why are we creating this perfect anatomical pose here in Visual3D to define the static trial? Well, since we have from the Xsens data collection all of these segment lengths, we can create our perfect anatomical pose. So we have a static trial that'll define our segments that then we will apply to our motion trial. And our motion trial will then be based on the actual subject's motion. Here we are simply calibrating the size of each segment to our subject. If you're wondering, like, well, how can we just define it that way? This is a generic model and you can use it, but we don't want it to be a black box. We want you to understand what's in there so you don't have any doubts about the validity of it and whether or not you should use it. Now, the right ankle center, if you go to landmarks, you'll see it starts at the right knee center, and within the lab, it goes in the negative Z direction, that length of the right shank. So you can see there's definitely a pattern occurring here where we define each segment based on that length, and that length is based on the length of the previous segment. So hopefully that's clear enough and it's not causing you too much confusion. If we go look at the right foot segment, you see we have the right distal foot as the joint center on the distal end. And this landmark is a little bit more interesting to consider. Because it starts at the right ankle center, which we know is vertically straight down from the right knee center. But then we have it going in the Y direction, the length of the foot. Now, the Y direction from the ankle center is in this direction. Actually, let me turn it so you can clearly see. So that's clearly how we got the right distal foot. But what's this marker? Right toe base. This is probably something that you're familiar with, coming from normal motion capture, as we would use a marker on the base of the second metatarsal that would be equivalent to that reference point. So in fact, under segments, we use right toe base as a posterior location to define the whole foot. So you can see each individual landmark that we're creating is based on the previous one, and we're either moving in a straight line down or a straight line to the side or forwards or backwards, but we're keeping it very simple so it's easy to keep track of. Now, if you were to look at the thorax segment, you can see it's defined from the L5 to the C7. And the C7, if we go look at landmarks, as you probably were expecting, is moving in the positive direction, the length of the thorax. So we're not going to go explain every single segment in detail or every landmark. There are a lot of them in here. By now, you should have gotten the concept of how each of these was defined. So as a brief overview, in case you ever need to know the specifics of how the Xsens model in Visual3D is defined, the easiest way to think of it is from Xsens, we are obtaining the segment height. Obviously, there are a few exceptions, like the foot, where it's actually the length of the foot rather than the height of the foot, but that should be an easy exception to understand. In this case, for the thorax, we are starting from the L5, and we are obtaining the distal end as the C7. So we have two reference points to define that axis of the segment. We then define another landmark, in this case the posterior landmark, which, if we look at landmarks, we go ahead and highlight it as posterior. See, it is based on the it's based on the hip mid marker again, and it's simply in the posterior direction, negative 0.1 in the Y. So that gives us that orientation, and that fully defines each individual segment. Now, the advantage you have using an Xsens system in Visual3D compared to really any motion capture system is that you pretty much don't ever have to go create your own model, because the Xsens system is always going to work exactly the same way. You're not dealing with different marker sets for different purposes. So having that, you can use this model for all of your Xsens data regardless of what motion is being performed. And in the next unit, what we're going to do is show you how to apply this model to any of your Xsens data.